Hi all, welcome back to our YouTube channel. In this video, we are going to introduce polyalphabetic ciphers. So let's get started. In the previous video, we covered all the monoalphabetic cipher, which included additive cipher, also known as shift cipher, multiplicative cipher, and affine cipher. In this video, we are going to introduce polyalphabetic ciphers, which are classified into 4 types, which are AutoKey cipher, Playfair cipher, Vigenère cipher, and Hill cipher. But before deeply understanding polyalphabetic cipher, let's see why do we need a polyalphabetic cipher at the first place. So why do we need a polyalphabetic cipher? To understand this, let's do the cryptanalysis of the previous monoalphabetic cipher. So in a monoalphabetic cipher, the mapping is always one-to-one and is independent of the position of the characters in the plain text. Let's understand this using an example. So consider the following plain text, which is hello, which is converted to the following cipher text. Let's look at the mapping of the characters in the plain text to the characters in the cipher text. So the following diagram represents the mapping. So here we can see the letter H in the plain text is mapped to the letter K, E is mapped to the letter H, L is mapped to the letter O, and O is mapped to the letter R. So we can see that the mapping is one-to-one. This implies that every time H occurs in the plain text, it will be replaced by the letter K in the cipher text, and the letter E in the plain text will be replaced by the letter H in the cipher text, and so on. And hence we can observe that both the L in the plain text are replaced by O in the cipher text. Due to this one-to-one mapping, the frequency of the characters in the cipher text is not changed. And hence it is prone to a statistical attack. And we have already seen in the symmetric key cryptography system video that in a statistical attack, the attacker uses an inherent characteristic of the English language to decrypt the cipher text. So in English language, the letter E is the most occurring alphabet, and hence the attacker will replace the most occurring alphabet in the cipher text with the letter E and use the same transformation on all other letters to retrieve the plain text. And this is why we need a polyalphabetic cipher. Let's take an example to understand this. So here the plain text hello is converted to the following cipher text. Let's have a look at the mapping of the characters in the plain text to the characters in the cipher text. So the following diagram represents the mapping. So here we can see the letter H in the plain text is mapped to the letter G in the cipher text. However, the letter E is mapped to 2 alphabets in the cipher text, that are W and K. Same goes for L, which is mapped to 2 alphabets, that are V and Z. And finally O is mapped to the letter B. So we can see there is one-to-many mapping in polyalphabetic cipher. And we can observe the same in the given example. Here the letter L is replaced by 2 different alphabets, that are V and Z. And because of this, the frequency is changed in the cipher text. And this is the reason why we need a polyalphabetic cipher. Now let's understand some properties of a polyalphabetic cipher. So in a polyalphabetic cipher, the relationship between a character in the plain text to a character in the cipher text is one-to-many. Due to this, it hides the letter frequency in the cipher text. And in a polyalphabetic cipher, each occurrence of a character in plain text may have different substitute in the cipher text, and is dependent on its position in the plain text. So we can see that in a polyalphabetic cipher, the encryption and decryption depends both on the face value and the position of the characters in the plain text. And since the encryption and decryption are dependent on the position, we have a key stream represented as K1, K2, K3 and so on. Here Ki is used to encrypt the ith character of the plain text to the ith character in the cipher text. And as you would have guessed, the plain text is a plain text stream represented by P1, P2, P3 and so on. Same goes with the cipher text, which is represented as C1, C2, C3 and so on. So this was a quick introduction to polyalphabetic ciphers. In the next video, we will cover all the remaining ciphers starting with AutoKey cipher. So that's it for the video guys. Thanks for watching the video, and if you have any doubt, please do let us know in the comment section below. And if you have found the video helpful, then do like and share the video with your friends and subscribe to Be The Best channel for more such videos. Meet you in the next video of the CSS series. Bye bye.